Do you like to live? If you're like me, and you do, you're probably going to need this molecule. Hi, my name's Tyler, and in this video I'm going to be talking about L-ascorbic acid, or more commonly referred to as the easy to spell vitamin C. Ascorbic acid is made up of 6 carbons, 8 hydrogens and 6 oxygens that are covalently bonded, and is a water-soluble polar molecule, giving it a molecular mass of 176.12 daltons. Ascorbic acid has several functional groups: an ester, 4 alcohols with hydroxyls, 2 of which are bonded to the alkene bonds between 2 carbons, a furan ring, which is an unsaturated ring of 4 carbons and an oxygen. Different properties given by the molecule's functional groups ester, alcohols, and alkene bonds contribute to the tetrahedral, trigonal planar, and bent geometries of ascorbic acid. Due to its chiral carbons, L-ascorbic acid also has enantiomers. Enantiomers, or optical isomers, are mirror images of the same molecule that cannot be superimposed onto themselves. Just like if you were to place your left and right hands palm upwards on top of each other, you wouldn't be able to form the shape of just one hand. One enantiomer, or mirror, of L-ascorbic acid is known as D-ascorbic acid. D-ascorbic acid has similar antioxidant properties as L-ascorbic acid, but lacks other important functional qualities, like its role in hormone production, the ability to synthesize neurotransmitters, and its ability to function as an enzyme cofactor in the production of collagen. L-ascorbic acid is perhaps most well known for its role in preventing scurvy. We need it to produce collagen, which is the main component of skin, bone, tendon, cartilage, and teeth, and humans can be made up of almost 30% collagen. Without enough of it, we get scurvy and our teeth fall out. Earlier, we touched on the fact that L-ascorbic acid is an antioxidant. It's given the power to neutralize free radicals thanks to these guys. To understand why, here's a little more on free radicals, and in particular, the hydroxyl radical. Basically, free radicals are groups of atoms with an unpaired electron in their outer orbital. They fly around inside our bodies until they bang into something they can steal an electron off. This could be a cell membrane, DNA, or just about anything else. And even Jeff Bridges can see how this will be bad.
Radical man.
L-ascorbic acid, somewhat given away by the name, is an acid. This means it is a proton donor. It gives up the N-acylic hydrogens, that is the hydrogens from the hydroxyl groups, that have one end attached to the carbons in the alkene double bond to neutralize the free radicals, before they can damage DNA or anything else. Importantly, when L-ascorbic acid is oxidized, it becomes dehydroascorbic acid, and not a free radical itself. And this is why it's classed as an antioxidant. This dehydroascorbic acid, not to be confused with the enantiomer D-ascorbic acid, can enter the cells where it's recycled via reduction into L-ascorbic acid, so it can be used once again. So whether you think it's important for its role in stopping free radicals damaging our DNA and other cells, or for the creation of enzymes in our body, or even just to help reduce the severity of the symptoms of the common cold, L-ascorbic acid, or dehydroascorbic acid, which we now know as vitamin C, is an important molecule to the body in many ways.